Hi everyone. This is day 2 out of 8 for us. I posted the lesson 4 and lesson 5 notes in Canvas. So if you found the videos, you probably found the notes too. So hopefully you printed those out so you can follow along with the video. So we're going to start with Module 3, Lesson 4. Shade each candy bar below to show how much each person ate. Then answer the reflection questions. So this is leading us into addition of fractions. So this is just the first part of it. So 1/5 of a candy bar would be 1 out of 5 pieces. 7/8 of the candy bar, 1, 2, 3, 4, 5, 6, 7 out of 8 would look like this. Jack ate 4/5. So there's 5 boxes, so we need to color 4. Sarah ate 7/10. I'm sure there's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need all of them but 3. And Alex ate 9/10, and it's the same as the one above. And Matt ate 5/8. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5. So this would be Matt. Okay, so let's turn to the next page, and you're going to have to keep referring to this. So based on the shared candy bars, who ate most of his or her candy bar? So when I'm looking, I see that Ronnie and Alex seem to have eaten the most. Notice when you make unit bars, some of you missed points on this on the test. They do all have to be the same length. So you have to be careful with that when you're using unit bars. But when you get two like these that are so close you can't really tell, we have to have another method to compare these two fractions. So we need to know which fraction is larger, 7/8 or 9/10. So we'll answer that it looks like Ronnie and Alex ate the most. Kind of hard to tell who's ahead of who. It looks like Ronnie at 7/8 and Alex at 9/10 ate the most. It is hard to tell which of the two ate more. So it looks like Ronnie at 7/8, that's a pretty bad 8, isn't it? And Alex at 9/10 ate the most, but it is hard to tell which of the two ate more. Okay, so now let's go ahead and do it with math and see if we can figure out who ate more. So you had this on your last test, where you had to rank fractions and decide which one was larger. They're both one piece away from the whole, right? So it's really hard to tell when they're just one piece. So we learned to find common denominators, and the smallest common denominator is 40, but I would guess a lot of you maybe would pick 80. I don't know. It doesn't matter whether you pick 80 or 40. I'll show you with both. So let's just pick 80. And what do I need to multiply 8 by to make it 80? That would be 10, right? So whatever I do to the denominator, remember I also have to do to the numerator. What do I need to multiply 10 by to make it 80? 8. And this is a process we're going to use later when we add and subtract fractions, find a common denominator. So that's what this is leading into. So Ronnie's turns into 70 out of 80 pieces, but Alex's turns into 9 times 8, 72. So imagine if you cut a candy bar into 80 pieces, how little those pieces would be, and he ate just 2 more. So that's why it was so hard to tell which ate more from the picture. We would have had to get a ruler and make sure all of our lines were perfect. This is an exact science. So we know for a fact that Alex ate more of the candy bar. And this is our justification here. So I just kind of put it all into one. Okay. So hopefully that's a review. That was on your last test. Kind of a warm up for us. So let's go ahead and go to the next page. So use the fraction circles, which we're not going to use because we already know how to do these kind of problems, to name 2 fractions equivalent to the given. And this is on the test, so this is good stuff to know. So I can make equivalent fractions. I can make millions of equivalent fractions. The rule is, as long as I multiply both the numerator and the denominator by the same number, I'll always have an equivalent fraction. So for instance, let's see, 1/3 is going to be the first one. What if we took 1/3 down here and multiplied each by 2/2? So what would our new fraction be? 1 times 2, 2. 3 times 2, 6. So there's another equivalent fraction. And if you typed them in, I have a calculator here. I know you don't have calculators yet. In the next module, you get to use calculators. So if I took 1 divided by 3, I get 0.33333333. If I take 2 divided by 6, I get 0.33333. So see how they're still equivalent? They don't look the same, but they are equal fractions. And the reason, 2/2 is equal to 1. If I multiply something by 1, multiply your age by 1. Multiply your shoe size by 1. If you multiply by 1, you still get the same number. Yes, it looks a little different, and it's not simplified now, but I get an equivalent fraction. So let's do another one. Let's just pick any number. Shall we multiply by 10/10? 10/10. That gives me 10/30. And if you want to test, if you don't believe it, no, we can't multiply 10 and it'd still be the same. But watch this. 10 divided by 30. Same number, 0.33333. So as long as you multiply by 1, the same number, numerator and denominator, you will always get equivalent fractions. So these would be 3. And of course, there's millions. I could multiply by 100/100, 1,000/1,000, 50/50. As long as I do the same number to both numerator and denominator, then I am good. Okay, let's do 1/4. 2/3 is down here. So we'll write the answers from 2/3 down there. So let's do 1/4 together, and then you can shut off the video and do 2/3 on your own. So 1/4. Let's pick different numbers than we picked before. Shall we say 3/3? And then do 1/4. And should we do 100/100? Just to make it fun. And so that leaves us with 3 over 12 for the first fraction, and 400, whoa, Kim, 100 over 400 for the second fraction. And you can see if you crossed out those two zeros, you'd still get 1/4. And you can see this simplifies to 1/4. 3 divided by 3 is 1. 12 divided by 3 is 4. So there are two equivalent fractions. So 3/12 and 100 over 400. So when I ask you this on the test, I just want you to know there's not just two answers. There's millions of answers. I'm just giving you two of them, but there are an infinite number of answers, just as long as you make sure it's the same number for both numerator and denominator. So go ahead and turn off the video and do letter C and then write your answers down here. Okay, I'm going to pick 5 over 5 for one of them. And you do have to write the 5 twice. I saw some of you writing this on the test, and that's not correct math to write that. That number is 10/3, because 5 is really 5 over 1, and that gives you 10/3. This gives you 10/15, which is correct. So don't write it like that where you only write the number once, because when you write 5 once, that means 5 over 1. So you multiply the top by 5, 10, and the bottom by 1 and get 3, which isn't an equivalent fraction. So make sure you write the number twice. And then let's pick, 20 over 20? Oops, wrong color. And so that gives us 10/15 for one of the fractions, which I can divide by 5 and get 2, divide by 5 and get 3. That's good. So 10/15 is one of them. And the other one would be 40 over 60, which is 4/6. And when you divide both of those by 2, 4 divided by 2 is 2, 6 divided by 2 is 3. So you can see it is equivalent as well. And like I said, you might not have gotten the same answers, but if you have a little calculator handy, you can just divide it out and see they're all equal to 0.66666666. Okay, we don't need to answer 3, so let's go ahead and go on to the next page. I'm going to skip around a little bit because I don't want you to have to watch a million videos, so I'm just doing the important stuff that's on the test. I don't think we need to do that, write another fraction for those, so let's skip to number 5. So we're going to skip number 4, because we don't need to write another fraction. I think we get it. So let's go on to number 5. So we're not going to use the fraction circles. Create one more equivalent fraction. So let's just do that. So forget all the other directions. Let's just create one more equivalent fraction, because you're not going to have the fraction circles on the test. So although it's nice to look at them and be able to see visually on the test, you have to be able to do it by hand. So the first thing I notice about all 3 of these is they can all 3 be simplified. These are all evens. 10's even, 12's even, 10's even, 8's even. These are not divisible by 2, but what are they divisible by? 3, right? So I can divide both of these by 3, so you can make equivalent fractions by dividing 2. Because when you divide by 1, take your age divided by 1, you still get the same age. So whether I'm multiplying by 1, 3 over 3, or dividing by 1, it doesn't matter. I still get an equivalent fraction. So this would be 3 over 4. And this one, they have a 2 common, so let's divide them both by 2. So whenever they're even, I always start with 2, unless I can see something real obvious that that's better than 2. So 8 divided by 2 is 4. 10 divided by 2 is 5. So these are equivalent fractions, as these are because I divided by 1.